Hello, welcome students. I am Rekha Thorat, Associate Professor. Today we consider some examples on infinite series, whether the series are convergent or not. Consider first series summation of 3 by 2 raised to n. We write given series in the solution. Summation 3 by 2 raised to n. It is a geometric series with common ratio 3 by 2, and this common ratio is greater than 1. Since this series is of the type 3 by 2 plus 1 plus 3 by 2 plus 3 by 2 raised to 2 plus dash dash dash. Here common ratio is 3 by 2, which is greater than 1, and by the result that geometric series diverges for common ratio greater than 1. Hence the given series summation 3 by 2 raised to n is divergent series. Next series is summation of 1 upon 3 by 2. In the solution we write given series. It is a p series of the form summation of 1 upon n raised to p, and we know the result that p series is convergent if p is greater than 1. Here p equal to 3 by 2. 3 by 2 is greater than 1. Hence by the result the p series summation 1 upon n raised to p is convergent for p is greater than 1. Series is convergent. So given series summation 1 upon n raised to 3 by 2 is convergent series since p equal to 3 by 2 is greater than 1. Next example is summation 1 upon root n. We write given series in the solution summation 1 upon root n. That means given series equal to summation of 1 upon n raised to half. It is also p series of the form n raised to p. Here p equal to half, which is less than 1. And by the result that if in p series, if p is less than 1, then the p series is divergent. So summation 1 upon root n is a divergent series. P less than 1 divergent. Hence given series is divergent. Now we consider summation 1 upon n. We write given series in the solution. We also know that summation 1 upon n raised to p for p equal to 1 series is divergent. Here also in given series p equal to 1 and given series is summation 1 upon n. So summation 1 upon n is a divergent series. This can be asked for objective also. The series summation 1 upon n is dash dash. It is a divergent series since it is a p series. Here p equal to 1 and this p series is divergent for p equal to 1. Or also summation 1 upon root n is dash dash. It is a divergent series since p equal to 1 half, which is less than 1, and p series is divergent for p is less than 1. Hence given series is divergent. Summation 1 upon n square. This is also p series of the form summation 1 upon n raised to p. P equal to 2 and 2 is greater than 1. P series p is greater than 1. Series is convergent. Here p equal to 2, which is greater than 1. Hence summation 1 upon n square is a convergent series. Next series is summation of 1 upon cube root of n square. We write given series in the solution. It is a p series. P equal to 2 by 3, which is less than 1. And we know that p series summation 1 upon n raised to p. If p is less than 1, then series is divergence. Hence given series summation 1 upon cube root of n square is divergent series. Next series is summation 1 upon n cube. We write given series in the solution. It is also p series of the type summation of 1 upon n raised to p. We write bracket for understanding. And for p greater than 1, given series is convergent. Here p equal to 3. Hence given, which is greater than 1, hence given series 1 upon n cube is convergent series. Next example is summation 1 upon cube root of n. We write given series in the solution. Here p equal to 1/3. P is 1/3, which is less than 1, and if summation 1 upon n raised to p is less than 1, series is divergent. Hence by this result, given series is a divergent series as p equal to 1/3, which is less than 1. Next example is summation of 1 upon n root n. We write given series in the solution. 1 upon n root n means n raised to 1 and n raised to half, that is n raised to 1 plus half, that is 3/2. And as 3/2 is greater than 1, p is greater than 1. This is the p series of the form summation of 1 upon n raised to p equal to 3/2, which is greater than 1, and by the result of p series, that is if p is greater than 1, the series is convergent. Hence the summation 1 upon n root n is convergent. Next series is summation of 1 upon n raised to 5/2. Summation 1 upon n raised to 5, it is a p series. P equal to 5/2 is greater than 1, and as p is greater than 1, the series is convergent series. Summation of 1 upon 4 raised to n. This is a geometric series with common ratio half, and common ratio 1/4, and as 1/4 is less than 1, it is convergent series. Since in geometric series, if common ratio is less than 1, then given series is convergent. Here common ratio is 1/4, which is less than 1, hence given series is convergent. Next example is summation of 2/3 raised to n. We write given series in the solution. 2/3, it is also geometric series with common ratio 2/3. Since the series is of the type 1 plus 2/3 plus 2/3 bracket square plus dash dash dash. Here common ratio is 2/3, which is less than 1, and hence the geometric series is convergent since this common ratio is 2/3 less than 1. Next example is summation of 5/3 raised to n. We write given series in the solution. This is also geometric series with common ratio 5/3. Series is of the type 1 plus 5/3 plus 5/3 bracket square plus dash dash dash. And here common ratio is 5/3, which is greater than 1. And if in geometric series, if common ratio is greater than 1, then given series is divergent. Hence summation 5/3 raised to n is a divergent series. Next example is summation of 5 raised to n. This is also geometric series since it is of the type 1 plus 5 square plus dash dash dash. Here common ratio is 5, which is greater than 1. Hence if this common ratio is greater than 1, geometric series divergent. Hence given series summation 5 raised to n is divergent series. Next example is discuss the convergence of the series summation of 1 upon n factorial. Here factorial sign is there. In the solution we write given series summation 1 upon n factorial. Here un equal to 1 upon n factorial, which is less than 1 upon 2 raised to n minus 1 equal to phi n for all n. Now phi n equal to 1 upon phi n equal summation of phi n equal to summation of 1 upon 2 raised to n minus 1 is a geometric series with common ratio half, which is less than 1. Hence it is convergent series. Hence summation of un equal to summation of 1 upon n factorial is also a convergent series by comparison test. Now we consider another example, summation 1 upon 2n square plus 3n plus 2. We write given series in the solution. Here un equal to 1 upon 2n square plus 3n plus 2. which is less than 1 upon n square, which is considered as Pn. Summation of Pn equal to summation of 1 upon n square. It is a P series, and P series is convergent if P is greater than 1. That is, P equal to 2 is greater than 1. Hence, this series is convergent, and since Pn is convergent, Pn equal to considered as 1 upon n square, and Un is less than this Pn. This Pn is convergent series, and Un is less than this Pn series. So that by the previous result, summation of Un is also convergent series by the comparison test. Now we consider next example, summation of 1 upon root of n plus 2 plus root of n. We write given series in the solution, summation 1 upon root of n plus 2 plus root of n. Here Un equal to 1 upon root of n plus 2 plus root of n, and we take Pn equal to 1 upon root of n. Hence, limit n tends to infinity Un upon Vn equal to limit n tends to infinity of, in bracket, root of n upon root of n plus 2 plus root of n equal to limit n tends to infinity in bracket root n taking common cancels, so we get 1 upon root of 1 plus 2 by n plus 1, and limit equal to half, which is not equal to 0. Hence, by comparison test, summation of Un and summation of Vn behaves alike, but we have taken summation of Vn equal to summation of 1 upon root n, which is equal to summation of 1 upon n raised to half, and it is a P series since P equal to half, which is less than 1, and we know that if this P series P equal to half, that is P is less than 1, given series is divergent, so that this series, given series, is divergent series. Now we consider next example, that is summation of, in bracket, n cube plus 1 bracket raised to 1/3 minus n whole bracket complete. We write given series, here Un equal to n cube plus 1 raised to cube minus n. We take n common, so that Un equal to n into bracket 1 plus n cube bracket complete raised to 1/3 minus 1 whole bracket complete. So we get Un equal to n into bracket 1 plus 1/3 into 1 upon n cube plus 1/3 into minus 2 by 3 by n cube n raised to 6 plus dash 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 bracket complete. Hence Un equal to 1 upon 3n square minus 2 upon n raised to 6 plus dash dash dash. Choosing Vn equal to 1 upon n square, limit n tends to infinity Un upon Vn equal to limit n tends to infinity n cube plus 1 in bracket raised to 1/3 minus n upon 1 upon n square, and limit of this sequence is 1/3 minus 2 by limit n tends to infinity of 1/3 n square cancels, taking common, limit of, in bracket, 1/3 minus 2 by 9 n raised to 4 plus dash dash bracket complete, and limit equal to 1 by 3, which is not equal to 0. Hence, by comparison test, the summation of Un and summation of Vn behaves alike. That is, if limit of Un upon Vn as n tends to infinity is not equal to 0, then both the series behaves alike. But summation of Vn equal to summation of 1 upon n square. It is a P series with P equal to 2 greater than 1. And we know that P series is convergent when P is greater than 1. Hence, given series is convergent. That means here in these examples, we have given this series and we have to take Vn. By comparing powers, we take Vn. That means by considering the powers in numerator and denominator, we consider Vn. Here we take Vn as 1 upon n square. In this example, we consider Vn as 1 upon root n.